Hi everyone, welcome to the sixth episode in the How to Teach series. Today we're going to be looking at how to find fraction of a number. My name is Nicola Ross. I am the Kit McGraw Education Sheffield Central owner, so we offer support to children in their maths and their English. So this session today usually comes in around the end of year 4 to the beginning of year 5. As you just log in and join the meeting, just give me a thumbs up and tell me the age of your child, and then I know where to pitch it at. So there are a couple of things that your child needs to know before you start doing fractions of number. Okay, so they are, you've got to know what a fraction of a shape is. Okay, so they need to be able to say, if I had 3/4, I know to split my circle into 4, and I've got 3 of them. So they need to be able to draw you 3/4 on a shape first. They need to understand what the numerator and the denominator are. So they need to know that the top number tells you how many the shape has been split in, how many you've got out of what it's been split into, and the bottom number tells you the total cuts. So in this case, I've cut it into 4, and I've got 3 of them. Okay. And then the last thing that's useful to know is times tables. They do speed things up a lot. Having said that, if I've got a child that doesn't know the tables, but that is ready for this, then I'll give them a times table grid like this one, or you see the one on the wall behind me, so they can use that. If you want one of these, if you just message me, let me know your address and I can post one of these out for you as well. Okay, so what do we mean by fraction of a number? So the question is going to be something like this: 3/4 of 8. So all it means is that your 8 is your whole one this time. So this whole is actually 8. And I'm going to divide it into 4 because it says it wants it splitting into 4 equal pieces. Like that, like that. So that's it split into 4 equal pieces. And then it says, so I've divided by 4, and then it says, out of how much would you make each piece if it was divided by 4? So 4s into 8 go 2. So that means each of these is worth 2. 2, 4, 6, 8. So I've got my whole one, I've split it into 4, so each of them is 2. There are 4 2s and 8. All right. We've got my 2, and then it says that I have 3 out of those 4. So I need 3 of them. So I need 1, 2, 3. So that's 2, 4, 6. So 3/4 of 8 would be 6. All right, is that okay? We'll do one more. Moved up a little bit. So now you've got 3/6 times 12. Times and of mean the same thing. Times is of is times. So it doesn't matter which way it's written, it's the same thing. 3/6 of 12. So this is now saying that it wants me to split my whole one. My whole one is 12. It wants me to split it into 6 equal parts. Just a little bit of help here. To make your circle into thirds, this is what kids find quite tricky. Draw a Y in the middle of the circle. That's your thirds. Okay, that makes it pretty equal if you're not me. And then each of those thirds I can split into 6ths. All right. So I've split it into 6ths. I've divided it into 6. Now you'll notice that I'm saying the terminology that I want to bring in later on. So I've split it into 6, I've divided it into 6. This is going to come in a little bit of time when we stop drawing this. So what does that mean for each section? How much have I got in each section if I divided it into 6 equal pieces? I shared it into 6. 6's into 12 go 2. So again, each of these sections is 2. 2, 2, 2, 2, 2. Okay. And then it wants me to have 3 out of those 6. Each one of them is 2. So I'm going to times it. Oh, that's terrible. I'm going to times it by 3. 3 2s, 2, 4, 6. So 3/6 of 12 is 6. Oh, it's, yeah. At the moment then. The other thing you can point out is if the numerator is half of the denominator, then it's always going to be a half. Okay. The numerator is half the denominator, it's always going to be a half. All right, just give me a thumbs up if that makes sense. All right. Now the reason I'm linking this to the drawing is because up to this point, you'll have been doing drawings. So draw a circle, split it into thirds, show me 2/3. So this bit has already got a brain pathway. The brain understands that bit. So now I'm adding in this bit. I want the child to make a link. So I'm making the link for them to start with. Link making is how children learn, or how anyone learns. It's a big, big part of learning theory. We'll just do a little bit of brain science. So, learning is building pathways in the brain. Okay, building a pathway is a little bit like sending a sheep through a field. Imagine this is a lovely field full of really long, luscious grass. If I send one sheep from this gate to this gate, it leaves a little path in the grass. If I were to send a whole flock of sheep, I end up with a big carved sheep path going straight through it. Okay, and it will probably dig into the soil as well. A big, deep path. This is your repetition. That path can be made stronger by sending a lot of sheep, so a lot of repetition, or by sending really heavy sheep. So learning experiences that the brain is really hardwired to pick up on. And we're going to talk about those in a little bit more detail in a moment. All right, so that's called long-term potentiation, LTP. Okay, now say I want to join something onto that. So in the case of this, we've drawn those circles and broken it into fractions. And I want to link that into the finding 3/4 of 8, so finding a fraction of a number. So I'm going to take this pathway and I'm going to get them to divert my sheep to a little bucket over here. Got a bucket of food. And I'm going to get them to divert over there. So this is a pathway that's associated with the first one you've made. And it's going to link to something else. And this is the fractions of number bit. So that's your fractions of shape. That's really solid. Now this is your fractions of number. So you come along your fractions of shape, understanding that bit, and then you can divert off to the fractions of number. It's an associated pathway. The child's made a link between the two concepts. And it's associated pathway, so it's called associated long-term potentiation, ALTP. Right, and that's why making links is such an important thing about learning theory, because you're actually making links in the pathways in the brain. It's really good for the kids to make the links themselves. So some children might not need you to draw the circles and split them up. They might have automatically done that themselves in the head, but I think it's useful to show the why it's all working. All right, are we happy with that one? If you want to give me a smiley face, that would be lovely. And I know everyone gets it. Okay. Right, so if we now move on, the terminology that I was using earlier, so I was saying you divide and then you multiply. So, let's say your child now understands that you split the whole circle into the bottom number, work out how many that's going to be, and then times it by the top number. I have a little trick now for the next bit. So say you now have a question like this. 5/9 of 45, or 5/9 times 45. What did I do before? I divided by the bottom number. I split my circle into 9. So I divided by the bottom. 45 divided by 9 is 5. And then, so each of my sections was 5. And then I times that by the top number to tell me how many I needed. I need 5. So 5 times 5 is 25. I divide by the bottom, I times by the top. Now, when we talked about the sheep going through the field, I said you can either do it with a lot of sheep or you can do it with really heavy sheep. The really heavy sheep are things that the brain is hardwired to pick up on. It's hardwired to pick on novelty. So things that are unique, it picks up on, or unusual. It's also hardwired to notice difference. So if you have novelty or difference, then they will be heavy sheep, so to speak. Play is another one. Especially young children are pre-programmed to learn fast through play. So play is a heavy sheep. And then the final one is movement. The brain wants the body to move. Okay, the brain's stimulated and learns naturally through the movement of its own body. So one way you can do this with this is put a little song and a little dance to this way of working out. For the heavy sheep reasons. Okay, so the little song is divide by the bottom and times by the top, and you have to do the wiggly dance in between. I've had many different variations of the dance that children come up with. Some of them like to stand up and do it. Some of them like to do it quietly under their breath. But divide by the bottom and times by the top. If we can move, another heavy sheep. Okay. And often now, when a child has this on their screen or on their paper, and they'll say, I don't understand, we just go, and they'll put the words in themselves. They'll remember what the song is so that they can learn the dance as well. Okay, so that is everything today that I wanted to cover. So we've looked at the fractions of a number, look at why you do divide by the bottom times by the top, and we've also looked at why you sing the silly song and do the little dance. They're heavy sheep, they're going to get that pathway carved much, much quicker. If there are any questions, just pop them in now and we'll have a look. If you want to go back and look at the other fractions lessons, they need to come before this. So just go back through the Facebook page or on the YouTube channel and you can find the other ones in there. Lovely. Okay, well, thank you very much for watching. I will see you all next week. Bye-bye.